Hi to everyone. MEM School of Engineering, Department of Mechatronics Engineering, online classes, subject robotics and machine vision system, unit number 4. Last chapter we discussed about some of the robot programming. So now we are going to discuss about the particular robot programming, the robot language, that is VAL. So in this chapter, VAL, it is another language developed by the augmentation of an existing language. Basic is VAL. It is developed by the Victor Scheinman for the Uniman Corporation in 1975. VAL uses simple words to describe operations to be performed by the robot, which leads to real-time programming as given below. So specify and transform the coordinates of positioning points both in the Cartesian system and the joint angles. Edit robot programs written in VAL. So manage the execution of user programs. So VAL provides for speed control, grasping, arm movement, and signaling in a simple, easy to understand framework. Of course, all of these routines are implemented by subroutines written in BASIC and translated by an interpreter. High efficiency could be obtained by the use of a compiled BASIC if necessary, but usually it is sufficient to call pre-compiled subroutines. The need for a signal to other robots and machines is handled effectively by the use of the interlock commands such as wait, signal, and delay, which take an action on the occurrence of specific events. So VL is a low-level language and calls, therefore, for detailed planning of all actions. So VL provides the executing commands suitable for Puma robot for the applications in assembly, arc welding, spray painting, and material handling. In VAL, both teaching and offline programming can be used in an effective way. This language is modified into VAL2 by adding some more instructions for the operator convenience. So these are the statement used in the VAL programming, that is move P1. So that means move to variable P1, position 1. Okay, learn P1. So learn P1 means recorded coordinates of P1, then moves P1, that is straight line motion. So there is a difference between move and move as. Example, move L. D move 4,125, that is incremental move joint 4,125 millimeter. Then define path, that is P1, P2, P3. We already defined the multiple number of paths. So which path we need to create, like that we need to define. That is define path. Then move path. We are moving to the particular positions. Then initial statements. Initial statement define the speed and executing process. So speed will be 0.5 Mbps, MP, MPS, then executive program 1. So speed 75 percentage, ultra has 75 percentage. So rapid V triple X. So other programming statements. So interlock and sensor commands. Wait to 20 come on, that is wait until signal on port 20 is on. Signal 10 on, that means switch 10 on. Switch signal 10, 6. So switch signal 10 analog to 6 volt. Then open and close, that is open and close the creepers. computations and program logic, then go to 150. So logical for a logical operation, if logical operations expressions go to 150. So these are the welding instructions used in the VAL. So W set, that is command set the speed, welding voltage and current as a voltage condition, welding condition identify by the number 1 to 4. W start starts welding under present welding condition and waving condition. BW end inactivates a welding start signal. For example, weld 0.5 means the welding spot for zero point 0.5 seconds. So crater fill instruction is used when crater filling is required at a welding end of the weldment. So this is the example of robot programming in VAL. So there are two types of path used in the program. For this image, we need to write a program in VL languages. So first program movement, move safe. Safe means it is a initial condition or some of the coordinate which we are using the without movement, that is move space. And then signal 6. Okay, signal 6 means we are going to use a 6 path. Then move internal movement. Then move location 1, location 2, location 3, location 4, location 5, location 6. Then move internal 1, move safe, signal 5, move safe, wait 12, signal 6, then move in inter 2, then move location 6. Then 7, 8, 9, 10, 11, 12. Because first we need to put the k, then we need to put the 5 value. So then move safe, signal 5 and end. This is the programming used in the k and 5 model analyze welding of some objects. Then palletizing program problem, that is PTP system. Assume that it is designed to pick up identical object from an unknown location and then stack the objects on top of each other to a maximum 6. So figures show the application. The object is a cube of 50 millimeter length. The robot's origin is to be assumed at the shoulder joint. The approach distance to pick up point is 100 millimeter. How to write a program? This is a workspace of VL. So this is a programming stack. Remark this program pick up parts from a text. So remark location, that remarks, then open I, then set B, then approach pickup, then moves pickup, then close I, departs, approach move B, open departs, type remark, then remark move. So then shift, then go to then speed way setting, then ready and end. These are the PTP system programming. These are the examples. Then advantages of offline programming. It can prepare program without using the robot so that the robot is available for other users. So previously worked out procedures and routines can be incorporated in the program. So late and cycle time of the operations can be optimized in advance. So sensors can be used to interact with the external environment and appropriate action can be taken in response. Existing computer-aided design and the computer-aided manufacturing information can be incorporated into the control functions through proper interfacing. So robot can be used to manufacture individual units by calling on previously developed routines. It would be impractical to do this guiding and attempting to match different paths. So programs can be run in advance to simulate the movements actually programmed without incurring the risk of damage. These are the some of limitations. That is, languages are difficult to learn. languages changes radially over time. So like these are the limitation of offline programming. Okay, this is the concept we discussed, that is VAL programming and offline programming. Okay, so thank you. We will see in the next class.